Hello and welcome to our lesson on solutions to quadratic equations. So we've looked at 4 different ways to solve quadratics so far, and along the way we've been talking about the different types of solutions that we get. I want to be a little more descriptive in how we determine what kinds of solutions we're going to have and how many solutions we're going to have and why we get these different types of solutions, and then we will continue to build on that. But there are basically 4 possibilities for solutions to quadratic equations. Again, we've seen these before. There are 4 different possibilities, and they are based on what we call the discriminant. So one way to discriminate, which I know sounds like a bad word, but one way to discriminate between the different types of solutions comes from the quadratic formula. So I have 4 different quadratics up here, and I've gone through all the work typing all that in, which, let me just point out, takes a little while, typing on all the work to solve these 4 quadratics. Now 2 of them happen to be factorable. So the first one here is factorable, the last one actually also factorable, and that's why we end up with these nice solutions versus these that don't look so nice. But there's a little more to it than that. So when the quadratics factor, we get what I'm describing as these nice solutions, these rational real and rational solutions. Where in the process of using the quadratic formula are we going to know that that's going to happen? Okay, so I solved all of these using the formula, even though again 2 of them are factorable. And what I want you to notice is, like in the first one here, when we plug into the formula, this part here, that's not so much affecting the final answers in terms of what they're going to look like. What determines what they're going to look like really is what is underneath the radical. This 3 squared minus 4 times 1 times negative 4, that ends up being 25. And because 25 is a perfect square, we end up with this nice rational number that I can then add to and subtract from the negative 3 and divide by 2, so we get these nice rational solutions. So one option for quadratic equations when you solve is, if you are using the formula, you get this perfect square underneath the square root, and that creates these 2 rational solutions. They are real solutions, right? Only real numbers are rational or irrational. So these 2 real and rational solutions. Okay? Now if you look at the next problem, what's going on in this guy when you plug into the formula? Again, the 5, 2, whatever, not so much dictating what the answer is going to look like. 5 and 2 are still in there, but notice this time we're stuck with the radical 21. This part underneath the radical gave us this square root of 21, and because that doesn't simplify, there isn't anything further we could do with these solutions other than approximate them. So because we had this, it was still positive, so we're still getting real solutions, but because we can't square root the 21 exactly, we end up with 2 solutions that are real, but they are irrational. So we have 2 irrational solutions. 2 irrational solutions. Again, both of these are real, so these are real. They're just rational. And these are real as well. They're just irrational. So again, this is determined by this part underneath the radical here. And if we look at the next guy, again, solving with our quadratic formula, underneath the radical, this time we end up with a negative 80. And now 80 is not a perfect square. Even if it was, let's say it was like a 25, the fact that it's negative makes the I come out of the radical. And that is why in this case we ended up with these 2 imaginary or complex solutions. So the 2 complex or imaginary solutions, these are going to happen if you end up with a negative under that square root. Okay? And then I got one more here. This guy, we ended up with only 1 solution. And underneath the radical, 4 squared minus 4 times 1 ended up being 0. And because the square root of 0 is just 0, the plus minus 0 isn't doing anything different. So we end up with just the 4 and the 8, just the 1 rational solution. Okay, 1 rational solution in here. And again, it is a real solution. It's just 1 real and rational solution. So again, all the reals are either rational or irrational. Okay? So that part underneath the radical that is dictating what kind of solutions we're going to end up with, we call the discriminant. Okay? We call it the discriminant because it discriminates between the types of answers we're going to get. It's going to tell you when we're going to end up with rational, irrational, complex, imaginary, or just one rational solution. So the discriminant has its we can call it a separate formula. We can say our discriminant d is just b squared minus 4ac. It's just that part underneath the radical. So what you might be asked to do is use the discriminant to determine the number of solutions you're going to have. Are you going to have one or are you going to have two? And what kinds of solutions are you going to have? Are they going to be rational, irrational? Are they going to be complex, imaginary? Okay? So if you calculate your discriminant and you get a positive perfect square, a positive perfect square would be like the square root of 25. It's positive, it's a perfect square. So a positive perfect square is going to get you two rational solutions. Okay, if you calculate your discriminant and you get a positive number, but it's not a perfect square, like the square root of 21, then you're still going to have real solutions, but they're going to be irrational. So you have two irrational solutions. If you calculated a negative for your discriminant, doesn't matter if it's a perfect square or not, if it's negative, that negative is going to come out of the radical as an I, so that's going to give you the two complex or imaginary solutions. And then if you calculate your discriminant as 0, a 0 underneath the radical is going to make the radical piece go away, and in that case you're left with just one rational solution. Okay, so these are the four options, and they're all based off that discriminant, which is the portion underneath the radical, the b squared minus 4ac part of our quadratic formula. Okay, so for these next four problems, we're going to use the discriminant to see what the answers would be like. So we don't actually have to solve and tell what the answers are. It's just how many would we get and what kinds of answers would they be. Okay? Now, since the discriminant comes from the quadratic formula, we do have to make sure that our equation is in standard form before we pick out a, b, and c, and it is here. So for number 1, a is 4, b is negative 12, c is positive 9. So our discriminant would be negative 12 squared, b squared, minus 4 times a times c, so 4 and 9. And make sure you're using parentheses, particularly on the negative squared. If you plug that into your calculator without parentheses, it's going to give you a negative when it should be giving you a positive. Okay? So make sure you're using parentheses, again, particularly around that negative square. And I wouldn't even, I mean, I know it's doable in your head, but I just don't want to make any silly mistakes. So I'm going to go ahead and just type this into the calculator, let it do all the heavy lifting for me. And that way we don't do anything silly. When I say we, I mean me. Okay, so we calculated a discriminant of 0. So again, think about what's happening here. If you were to plug this into the quadratic formula and you got a 0 underneath the radical, the 0 underneath the radical is going to make the radical go away, which is only going to leave you what's in front of the plus or minus and then what's in our denominator, so there's just going to be one solution. So d equals 0 tells me that this is going to have one rational solution. One real rational solution. Okay? Let's try that again. And number 2, again, we want to make sure this is in standard form, so I would subtract the 2 over before picking out a is 10, b is negative 1, and c, which is negative 2, on the correct side of the equation. So the discriminant here would be negative 1 squared minus 4 times 10 times negative 2, 4 times a times c. So in this case, we're looking at negative 1 squared minus 4 times 10 times negative 2, and we end up with 81. So again, think about what would be happening here if you were using your quadratic formula to solve and you ended up with an 81 under the square root. Well, you could take the square root of 81, you'd get 9, which you could add and subtract from the number in front of the plus or minus, and you could divide by what was ever in the denominator, and so this is going to lead to 2 rational solutions. Okay, Moving right along here, same thing. So A equals, in this case, 1. B is going to equal -5. C is going to equal +3. So the discriminant is going to be -5 squared minus 4 times 1 times 3. So in this case, you like how I'm cheating here and not retyping everything. It's not cheating, it's being faster because I'm already slow here. Goodness. Okay, so we end up with 13 this time. So if we were solving with our quadratic formula and we got a 13 under the radical, that would be as far as we could go, unless you wanted to approximate. So this is going to be 2 irrational solutions. And then one for you to try if you're feeling good about this, although I'm sure you could guess just based on what's happened so far what the answer is going to be here. But let's see. A should be 1. B should be -2, C should be +4. So this discriminant is going to be a -2 squared minus 4 times 1 times 4. B squared and 4 times A times C. So in this case, -2 squared minus 4 times 1 times 4. And we end up with a -12. So a -12 under the radical, if we were using our whole quadratic formula to solve, that not only could the 12 simplify, but the negative is going to make that an imaginary or complex solution. So 2 complex or imaginary solutions. Okay, not so bad. So the discriminant is going to dictate what kinds of solutions we're going to have and how many solutions we're going to have. So you should be able to calculate the value for the discriminant and then use it to interpret what the solutions to that quadratic equation are going to look like. Okay? Furthermore, in terms of solutions to quadratics, you should be able to work backwards. So a couple things, right? We've talked about ways to solve. If I give you a quadratic equation, you should be able to find the solutions. You should now also be able to use the discriminant just to determine what the solutions are going to look like. And you should also be able to work backwards, meaning if I give you the solutions to a quadratic equation, you should be able to tell me what quadratic equation produces those solutions, which might sound a little intimidating, but it's not. Okay, let me just show you real quick here. Let's say I gave you x squared plus 3x plus 2 equal to 0, and I said solve it. Well, hopefully you're recognizing this is factorable. Factors of 2 that make 3 would be 2 and 1. So right away, this would factor into x plus 2, x plus 1, which means our solutions would be -2 and -1. Okay? So now I'm saying instead of going this way, we have to work backwards and get back to that standard form. But instead of jumping all the way to that standard form, what if we could just jump to this step first? If -2 was a solution, it had to be because x plus 2 was a factor, right? And if -1 was a solution, it had to be because x plus 1 was a factor. So again, let's say 5 was a solution, and let's say -4 was a solution. If 5 is a solution, it's because we had x minus 5 as a factor. And if -4 is a solution, it's because I had x plus 4 as a factor. Now, if those are the factors, that's the factored form of my quadratic equation, all I got to do is multiply it out to get the standard form. So x squared plus 4x minus 5x, which leaves me minus 1x, and then minus 20 equals 0 is the quadratic equation that produces those solutions. Okay, so it might have sounded a little scary, but it's actually pretty easy. Let's say, I'm going to put a variable in there. If, let's just say C. Let's say C is a solution to our quadratic equation. I don't want to use x because it's going to put too many variables. If C is a solution to a quadratic equation, then x minus C has to be a factor, right? So 4 was a solution, x minus 4 was a factor. If -5 was a solution, then x minus the negative, so plus 5, would have to be a factor. Okay, so whatever our solution is, x minus that solution, so in the binomial, right, it's the opposite of your solution, has to be a factor of your equation. So you're going to put the opposites of the solutions, right? Solutions 5, -5 goes in. Solutions -4, +4 goes in. You put the opposites of your solutions into the factors, and that's going to yield the factored form. This gives the factored form of the equation. And you might, in your assignment, be asked for the factored form, but you'd have to multiply out those factors to get the standard form, okay? And then just make sure that in the process here, your equation is equal to 0. If you don't actually put the equal sign and the 0 at the end, then you don't have an equation at all, and the solutions wouldn't be solutions to this thing that would not be an equation, okay? So just to keep it proper, make sure that equals 0 is at the end. So here again, if x equals 5 is a solution, that means that x minus 5 is a factor. And if -1 is a solution, then x plus 1 is a factor. And again, equal to 0 is now an equation that has those two solutions. So if I said what's the factored form of the equation that contains those two solutions, there it is. Now if we wanted the standard form, we're going to multiply this out. So x times x is x squared, x times 1 is 1x. Here we get a -5x, and then -5 times 1 is -5. And then combining those like terms, x squared minus 4x minus 5 equals 0 is our standard form. So again, just for future reference, this is the factored form. And this is the standard form. Okay. And let's try another one. Ooh, fractions. Are we scared? I hope not. It's just like bottoms up all over again, okay? If we're going to have this binomial, it's going to have an x in it, right? If there's a divide 3, that's what the bottom of that fraction means. If there's a divide 3 in that answer, it's because there's a times 3 in the factor. And if there's a +2 up here, a +2 there, it's because there was a -2 here. So bottoms up, right? Bring the bottom up in front of the x. So 2/3 as an answer means 3x minus 2 has to be a factor. Remember, we want the opposites. And then, oops, I still have my eraser on. If -1/4 is an answer, then 4x plus the 1 had to be a factor. So 4x plus 1 had to be a factor. Again, the opposite of minus is plus. The opposite of divide 4 is times 4. Okay, again, bottoms up makes that sort of makes sense. Okay, so now this is a factored form. If we multiply this out, that's going to give us 12x squared, and then plus 3x, and then minus 8x, and then minus 2, and then combining like terms, 12x squared minus 5x minus 2 is our standard form of that equation. Okay, not so bad. Now how about number 6? Maybe a little bit tricky. How are we supposed to write a quadratic equation when we're only given one of the solutions? Well, what if there is only one solution? What does that mean about our quadratic equation? So let me back up to here, right? When do we end up with one solution? We end up with one solution when we get to 0 under the radical, but that's not really helpful, right? So let's go back to the actual equation, 4x squared plus 4x plus 1. Let me take you to a second page here. 4x squared plus 4x plus 1. This is actually factorable. Factors of 4 that make 4 are 2 and 2. And if I divide them both by 4, they both reduce to a half. And what happens is I get 2x plus 1 and 2x plus 1. And this gets me a solution of -1/2. And this gets me the exact same solution. So we have one solution. Technically, we have two solutions, but it's the same solution twice, so we don't repeat it. Okay, so when we end up with one solution, we actually have two. It's just the same solution twice. Or think about this again, what this is saying. This means 2x plus 1 squared is equal to 0. So if we were to take the square root, that's square root of 0, right? There's that same thing we saw in the discriminant. Doesn't give us two different answers. So if we're given one solution, we just have to recognize it is the same solution twice, okay? So one solution means the same solution's happening twice. So x equals 3 and x equals 3 means x minus 3 is going to be a factor twice. So x squared minus 3x, and then plus 9. And combining like terms means x squared minus 6x plus 9 has to equal 0 is the standard form for our equation. So if you're only given one solution, if your quadratic equation only has one solution, technically it still has two, okay? It's just the same one twice, so we don't state it twice. All right, how about this next guy? This is a little strange. X equals plus or minus 2i. Okay, this means that positive 2i is a solution, and it means that negative 2i is a solution, okay? So this might feel a little weird, but we can do the same thing here, where if I said 5 is a solution, that x minus 5 is a factor. If 2i is a solution, let's say x minus 2i is a factor. And if negative 2i is a solution, let's say x plus 2i is a factor. Now I know when we factor, we don't see any factors that look like that, but it's still true, right? If you have a number as a solution, x minus that number is a factor. So let's multiply this out, because the factored form does not look reasonable here. If we multiply this out, we're multiplying conjugates here, right? We're going to get an x squared, and then this weird 2xi, and this weird negative 2xi. Those are going to cancel, and then at the end here, negative 2i times positive 2i gives me negative 4i squared. So again, these cancel, and what happens with I squared? Well, I squared is equal to negative 1, so this is really negative 4 times negative 1, which makes it a positive 4. So x squared plus 4 equals 0 is our equation. And that should make total sense, guys. Look, if I went back and solved this, I would have to subtract the 4 over, and then take the square root. And what do I get? Well, I would get plus or minus 2i, okay? So if you saw that before doing all that work, totally fine to jump to the equation. If not, the same work we did before we can use here. All right, so we can do the same thing on this one. If you feel comfortable, then try it out. But again, this is saying that 2 radical 3 is a solution, and that negative 2 radical 3 is a solution. So I could put x minus 2 radical 3 and x plus 2 radical 3 as factors. And I know that we don't see factors that look like that, but we can still use this to get to our standard form. So x squared here, and this 2x radical 3 and negative 2x radical 3 are going to cancel. And then at the end here, we get a minus 2 times 2 would be 4, and then 3 times 3 would be 9. And so again, these cancel, and we have x squared, and then 4 in radical 9 is really 4 times 3, and 4 times 3 is 12. So x squared minus 12 equals 0 is our equation. And again, that would totally make sense. If I was to solve this, I would add the 12 over, and then take the square root. And I'd have to put in a plus or minus, and break this down, and a 2 would come out, and a 3 would stay, and those are my two solutions, okay? So it looks a little strange, and again, if you could have seen that answer without doing all that work, that's totally fine. Now, the really hard one, or interesting one, I want to actually show you another way to look at this. I could do the same thing here, okay? This is saying that x equals 1 plus radical 3, and x equals 1 minus radical 3. So these are your two solutions. So I could go x minus this whole thing, which would be a minus 1 and a minus radical 3. And I could say x minus this whole thing, which would be a minus 1 and a plus radical 3, and multiply that out. But now 3 terms times 3 terms, that's going to give us 9 results when I multiply, and that's a lot of stuff to organize, which is totally fine. So I'm going to keep going with this, and then I want to show you another way, okay? So if I was to multiply, just so I can try to stay organized, x times x is going to give me an x squared. X times negative 1 is going to give me a negative x. and x times radical 3 is going to give me an x radical 3. And now here, negative 1 times x is a negative x. Negative 1 times negative 1 is going to be a positive 1. And negative 1 times radical 3 is going to be a negative radical 3. And then negative radical 3 times x is a negative x radical 3. And negative radical 3 times negative 1 is going to be a positive radical 3. And then negative radical 3 times radical 3 is going to be a negative radical 9. Negative radical 9. Okay? So all together, what am I looking at here is, let's see. I got an x squared. These cancel. These cancel. These cancel. And this is really going to be a negative 3 here plus the 1, which is a minus 2. And my apologies, these don't cancel. Gosh, guys, look what I almost did. A negative and a negative don't cancel. Negative positive cancel, same thing here, but that makes a negative 2x. So this should be a minus 2x, and then again a minus 2 equal to 0 for our equation. Okay, now if you like that, totally fine. That's a viable option, and that's exactly how we did all of the others. But for me, multiplying those three terms and those three terms creates a mess. And it's not so bad, like I'm doing this in color, so I can kind of color coordinate. And if you're, color coordinating too, then maybe you're good at organizing. Totally fine. But I want to show you another way. So you've got options. I'm going to leave that there. Let me see if I can fit in this other way. That's one option. And I got to clean this because that's bothering me. Okay, so one option. The other option is to work backwards. Okay? If x is equal to 1 plus or minus radical 3. Let's think about this. When I said x equals 3 was a solution, technically I could subtract that 3 over and say x minus 3 equals 0, and that's how I got my one factor, right? So I can use that process here. If I've solved and gotten down to this, let me unsolve. Instead of putting everything or taking everything away from the x, let me put it back. So if I was going to unsolve this, I would subtract the 1 over, and that would give me x minus 1 equal to plus or minus radical 3. So the opposite of that positive 1 is a minus 1. So now here, what's the opposite of taking the square root? It's squaring. So if I'm going to unsolve this, I'm going to square both sides. Square this side and square this side. So here I have to multiply an x minus 1 by an x minus 1. And over here, the square root of 3 squared is going to give me a 3. So I have an x squared, a minus x, and a minus x, and then a plus 1 equal to 3. So that's going to be an x squared minus 2x plus 1. And actually, let me do this here. I can subtract this 3 over from the 1, and so that gives me my minus 2 equal to 0. So there's two different ways to approach that problem. I don't know if either one looks easier for you. I prefer the second way, but whatever makes sense in your head, okay? Now, I'm not going to give you probably a ton of those to do. It is work you should be able to do, but I'm more concerned with you understanding that if a number is an answer, then x minus that number is a factor, and we should be able to take our solutions and work backward to get to our equation. Okay, so if you got some practice problems to work on, you got a couple different ways that you can work on those. If you find yourself running into any issues and needing some extra help, then by all means just reach out. All right, guys, take care.